They're just dense and hard mud, really. Simple impressions left behind. But these aren't just any old tracks. These are a 1.5 million year old snapshot of a morning when two entirely different kinds of humans stood here, almost toe to toe on the same ancient lakeshore. Imagine that. One set of prints belongs to a tall, long-striding individual, built like an Olympic sprinter, covering ground with purposeful strides. The other? Shorter, broader, with feet that look more like living climbing boots, designed for stability, not speed. Who were these mysterious figures? Why were they at the same lake on the same morning? And what on earth happened next in this incredible silent drama? This isn't just a story etched in stone. It's a profound glimpse into a world we thought we understood. The year was 2007, and a team from the National Museums of Kenya was meticulously surveying the ancient sun-baked shores of Lake Turkana. This region, often called the cradle of humanity, is a treasure trove of our past. On this particular day, something remarkable happened. Natural erosion, a relentless sculptor of the landscape, had peeled back a layer of volcanic ash. It was like lifting a dusty curtain on a stage that had been set 1.5 million years ago. And there, instead of the usual fossilized bones they might expect, were footprints, dozens of them, perfectly preserved, frozen solid in cement-hard sediment. It was an astounding find, made all the more incredible by the precise geological context. A nearby volcano had erupted, blanketing the area in a thin, powdery layer. Then a stroke of luck. Rain had fallen, turning that fine ash into a sticky goo. Every passerby, every animal, every hominin that crossed its path left a record. Crucially, another ash layer fell soon after, sealing the entire scene like a cosmic envelope. An instant time capsule. Back in the lab, scientists like Dr. Neil Roach from Harvard pored over these ancient imprints. They weren't just looking at random marks. They were reading a story written in biomechanics. Dr. Roach and his team meticulously measured stride length, foot pressure, and toe depth. The larger athletic set of prints, they discovered, perfectly matched the known anatomy of Homo erectus. Tall, with springy arches, and a modern heel-to-toe push-off that screams efficiency. These were the long-distance runners of their day. Then there was the second set. These belonged to Paranthropus boisei, often nicknamed Nutcracker Man, due to their incredibly robust jaws and gorilla-sized molars. Their feet were broader and flatter, adapted for stability and power, but certainly not for sprinting. The Paranthropus individual, however, was ambling, perhaps foraging for roots right at the waterline. And here's the kicker. This means they walked across that same patch of earth within hours, maybe even just minutes of each other. For decades, if you opened a textbook on human evolution, you'd probably see a neat, tidy diagram depicting our lineage as a ladder. One species dies out, the next, smarter one takes over. These footprints? They absolutely blow that tidy little ladder to smithereens. What we have here is concrete evidence of two distinct human species, with different diets and different body types, sharing the very same beach at the very same time. There's no sign of a fight, just calm coexistence. It shatters the old linear narrative and replaces it with something far more fascinating. A bushy tree of evolution where multiple hominin species thrived, overlapped, and interacted. Let's really imagine that lake at dawn, 1.5 million years ago. The air is cool, a thin mist hangs over the water. Flamingos wade in the shallows. Our Homo erectus individual is already on the move, a simple stone hand axe in hand. They're after meat, perhaps tracking a waterbuck carcass upstream. Their survival depends on their wits, their tools, and their ability to move. Meanwhile, Paranthropus wakes a bit later, perhaps having slept closer to the lake. Their breakfast isn't meat. It's last night's fibrous tuber, chewed with those powerful jaws. Then, they lumber down to the waterline for breakfast sedges. They spot each other. Eye contact lasts a second. A quick predator check, a competitor check, then both go back to business. They are neighbors, both dependent on the lake, yet extracting different resources in different ways. This incredible discovery highlights a fundamental divergence in early human evolution. Homo erectus had relatively small teeth, but they compensated with big brains geared for problem-solving and innovation. Their intelligence allowed them to adapt, to create tools, and to master their environment. Their cognitive flexibility was their superpower. Paranthropus, on the other hand, bet everything on its mouth. Massive jaws, huge molars. They were living food processors, perfectly adapted to a diet of tough plants. Same landscape, opposite solutions to the challenge of survival. The footprints prove both bets worked, at least for a geological heartbeat. Natural selection wasn't voting for best, it was running parallel experiments, each valid and successful in its own right for a while. So, who wins this evolutionary face-off? And now for the spoiler, if you can even call it that, for a story 1.5 million years in the making. Homo erectus is the only one whose footprints lead out of that ash layer and into the next million years of the fossil record. Paranthropus vanishes from the fossil record around 1.2 million years ago. It's a sobering thought, isn't it? Why did one thrive while the other faded away? The reasons are complex, but climate shifts, vegetation changes, and the ability to range farther for food probably tipped the scales. Homo erectus's adaptability, their varied diet, their advanced tools, their greater mobility, and their social cooperation gave them an edge when the environment became less predictable. Paranthropus, with its specialized diet, might have struggled when its preferred food sources became scarce. Still, their shared morning commute, that fleeting encounter on the lakeshore, tells us the disappearance wasn't a Hollywood battle, a dramatic clash of titans. It was likely a gradual, silent process. Just two cousins reading the same changing weather report, the same shifting landscape, and responding differently, with different outcomes. It's a powerful reminder that evolutionary success isn't about superiority, but about adaptation to an ever-changing world. But here's the real kicker. The profound secret these ancient tracks whisper to us. The overlap in time and space, that moment of shared existence, was incredibly tight. Even the pollen embedded in the same ash layer tells a story. The lake was shrinking. Resources were getting patchy. This wasn't some idyllic Garden of Eden. Coexistence wasn't easy. It was necessary. Survival demanded it. These tracks are the first direct evidence that early humans lived cheek by jowl, not in some bountiful paradise, but in an ecosystem that was already starting to wobble under pressure. It paints a picture of a world where competition for vital resources like water and food was increasing. Survival wasn't just about brute strength or big brains alone. It was about flexibility, timing, and maybe, just maybe, a bit of luck on one particular Tuesday 1.5 million years ago. If you're hooked on stories written in stone and the incredible narratives of our ancient past, then hit that subscribe button. New prehistoric secrets drop every week, and you won't want to miss them. Now, you might be wondering, how can scientists be so precise about a date 1.5 million years ago? It's not like they found a calendar. The answer lies in the incredible geological clock embedded within volcanic ash. Volcanic ash contains rare earth elements, and as it cools after an eruption, tiny iron minerals within it align themselves with Earth's magnetic field, locking in a magnetic signature. Geologists can then compare that specific magnetic orientation to a known sequence of Earth's magnetic field reversals, those times when magnetic north literally flips to magnetic south. It's like having a universal geological barcode. By matching the magnetic signature of the ash layer to the global record of these flips, they can pinpoint the exact time the ash cooled. Bingo. 1.53 million years ago, give or take a mere 7,000 years. It's an astonishing level of precision. Even with such incredible detail, these footprints leave us with so many tantalizing questions. No female footprints, no kids, just two adult individuals. Were they scouts, outliers, or perhaps exiles from their groups? And why no tool marks in the ash? Homo erectus definitely carried tools, but did our individual simply not need to use his axe right then? Every answer we uncover seems to spawn three new questions. What were their social structures like? Did they avoid each other, tolerate each other, or was there some form of interaction we can't yet detect? That's the beauty of science, isn't it? It reminds us that our past is still very much a mystery waiting to be unraveled. Today, only one human species walks the planet. Us, Homo sapiens. But if we look closely, we carry ghost DNA from Neanderthals, from Denisovans, and perhaps even from earlier groups. The Kenyan footprints are a powerful reminder that multi-species mornings are a very real part of our past. It makes you wonder, doesn't it? If the climate or the stars had shifted differently, there might still be two of us, or even three or four, tipping our hats at the shoreline, sharing this planet. The story of Homo erectus and Paranthropus isn't just ancient history. It's a mirror reflecting our own journey, our own challenges, and our own place in the grand tapestry of life. Next time you stroll along a lake, a riverbank, or even a sandy beach, glance behind you. Those temporary marks you leave are a fragile, fleeting message to the future, just like the ash at Turkana. These ancient footprints prove that coexistence isn't a fantasy, it's our history. Whether we share the planet with cousins of a different species or simply with each other in our incredibly diverse human family, the lesson from 1.5 million years ago is simple yet profound. Keep walking, keep adapting, and perhaps, just perhaps, someone will marvel at your tracks a million summers from now and wonder about the story you left behind.